Hello, Algebra 2 students. It's almost 3 a.m. I have a purring kitten in my lap. Let's solve some radical equations. Okay, so let's jump right in. Okay, starting with square root equations. To solve a square root equation, you're going to isolate the square root. Isolate the square root. You're going to square both sides to eliminate the square root, and then you're going to solve for the variable. So let's try it. Okay, so here we have our first example. We've got 3 plus the square root of 2x minus 3 is equal to 8. So we're going to start by isolating that radical. So by isolating that radical, we're going to do that by subtracting this 3 from both sides of this equation, giving me the square root of 2x minus 3 is equal to 5. And then we're going to square both sides of the equation because it gets rid of that radical sign, giving me 2x minus 3 on the left and giving me 25 on the right. So we're going to add 3 to each side. We've got to isolate this variable now. 2x is equal to 28, and that means x is 14. And you can quickly do the mental math. 2 times 14, 28 minus 3, 25. Square root of that is 5 plus 3, 8. Yes, it does indeed work. Next one, why don't you pause it and try it? Okay, I'm going to add 5 to isolate this radical in this case, giving me square root of 4x plus 1 is equal to 5. We're going to square both sides. Square both sides, giving me 4x plus 1 is equal to 25 again. Subtracting the 1 from each side, 4x is equal to 24, and x is 6. So 4 times 6, 24 plus 1, square root of 25 is 5 minus 5 is 0, and it works. But what if the radical in question is not a square root, or not merely a square root? Let's look at solving an equation with a rational exponent. So something that's not just a square root, so a rational exponent like a fraction. To solve, we're going to isolate the exponential expression. Isolate that exponential expression. We're going to raise both sides of the equation to the multiplicative inverse of the exponent. And that's going to get rid of that exponent. That's going to get rid of that expression with an exponent for us. We're going to solve for the variable, and finally we're going to check for extraneous solutions. Let's try a few. Okay, so here we have 3 times the quantity x plus 1, which is raised to the 2/3 power, is equal to 12. Let's go ahead and get rid of the 3, the multiplied 3, giving me x plus 1, the quantity to the 2/3 power, is equal to 4. So what we're going to do is we're going to raise both sides of this to the 3/2 power. The 3/2 power. So this whole side here to the 3/2 power. And look what happens here. Power of a power with exponents, power of a power multiply. Well, the 3's and the 2's cancel. So now you have a 1 there. So you have x plus 1 to the first power. So just x plus 1. And then on the other side you have 4 to the 3/2 power. So that's the square root of 4 raised to the 3rd. Or 2 to the 3rd, which is 8. So I have x plus 1 is equal to 8, and x is equal to 7. And then you're going to go back and you're going to plug it in. 7 plus 1 to the 2/3 power is indeed, 7 plus 1 is 8. To the 2/3 power would be cube root of 8 would be 2, squared be 4 times 3, 12. So that one works, no problem. Okay, take the time to write it out if you need to see it. Now number 2, we're going to start generally the same way. So we're going to isolate this radical expression. So I'm adding the 1, okay, and that will give me 3 times the 5th root of x plus 1, the quantity to the 3rd, is equal to 24 instead of the 25. We're going to divide off the 3, and we're going to have 5th root of x plus 1, the quantity to the 3rd, is equal to 8, and we're going to rewrite this side. It's x plus 1, not the 5th power, but now we're going to make it to the 3/5 power is equal to 8. Now we're going to raise both sides to the reciprocal of 3/5, which is 5/3. And it works out well to raise 8 to any power with a denominator of 3 because 8 is a perfect cube. Well, what's this going to give me? Well, this is going to cancel and give me x plus 1, just like the top one, the first equation we did. And this is going to be the cube root of 8 raised to the 5th power. Well, that's cube root of 8 is 2, raised to the 5th power is 32. So now, going up here, I have x plus 1 is equal to 32. Subtract the 1 from each side, and x equals 31. Whew. Okay, let's do a couple more. The next two are ones that we definitely have to check for extraneous solutions. You're not really going to have to worry about that unless you have a variable in addition in the equation that's in the equation but not in the exponential expression. Let's take a look at one. So this is what I'm referring to. If you look at number 3, you have a variable on the other side. See this variable over here, this x over here. So we're still going to start the same way. We're going to isolate the radical. So we're going to add 5 to each side, giving me square root of x plus 7 is equal to x plus 5. We're going to square both sides. So we'll square both sides. And notice, yes, that means on the right-hand side we're going to have to FOIL that. So let's come up here. So when we square the radical, we just get x plus 7. But when we square the x plus 5, we're going to get x squared plus 10x plus 25. And yes, that means we're going to probably have to do some factoring here. So let's subtract the x and the 7, lining it up under the like terms. And what does that give me? A 0 there, and an x squared plus 9x plus 18. And that is factorable. So factors of 18 that add up to 9. And those factors are 6 and 3. Alright, going to move my equals 0 to the other side. That means my solutions are negative 6 and negative 3. However, when I go back to the original equation and I start plugging them in, we have a problem. I'm running out of space for my second equation, so I'm going to do my checking part. I'm going to do it up here. Okay, so negative 6 plus 7, the square root of that, so negative 6 plus 7, and then minus 5. Does that equal negative 6? That's what I'm looking at here. Negative 6 plus 7 is 1, so the square root of 1 minus 5 is definitely not equal to negative 6. Because I can't get a negative 1 out of the square root of 1. I can only get a positive 1. So that negative 6 is not going to work. It's an extraneous solution. Let's check the negative 3. Negative 3 plus 7 in the radical sign minus 5. Will that equal? And then that's x on the other side again, so that's the negative 3. Well, this is the square root of 4 minus 5, which is 2 minus 5, which indeed does equal negative 3. So we end up with the negative 3 as the only solution for the third problem. Now, this one's even more different. We've got that square root of x hanging out by itself. So we're still going to isolate the other radical. Alright, so I'm going to have square root of 2x plus 1 is equal to the square root of x, make sure my equal sign's nice and long, square root of x plus 1. And we're going to switch to a different color, square both sides. So left side is easy, 2x plus 1. Right side's a little bit different. We're going to have to FOIL it. So x squared times x squared is x, plus 1 times x square root of x is square root of x, plus another one, so 2 root x. Don't worry, we'll deal with that in a minute. And 1 times 1 is 1. Let's get everything, let's get the radical isolated again. So we're going to subtract x from each side. We're going to subtract this 1 from each side. We're going to be left with x, this cancels, equals 2 root x. We're going to square both sides. Well, let's divide by 2 first. So let's divide off that 2. Whoop. So that's x over 2 equals the square root of x. We're going to square both sides. And we're going to get x squared over 4 equals x. Okay, well that didn't turn out very attractively. Let's multiply by 4 and get rid of that fraction. That's going to give me 4. Oh, wait a minute. No, it's not. Hold on. I apologize. That's going to give me x squared equals 4x. We're going to get them both on one side. X squared minus 4x equals 0. And we're going to factor out an x. Don't know why I put the extra parentheses there. Pretend it's not there. Okay, hold on. Got to add another slide in because I'm completely out of space. Sorry about that. Finishing up, we get x equals 0. and x minus 4 is equal to 0, or x equals 4. Then we got to go back and we've got to double check our solutions. So here's the equation again. We're going to plug in, first we'll plug in 0. So 2 times 0 plus 1 minus the square root of 0, is that equal to 1? So 2 times 0 is 0 plus 1 is 1. Square root of 1 minus 0, check, equals 1. Okay, good. Let's check the other one. 2 times 4 plus 1 minus the square root of 4, does that equal 1? So 8 plus 1, 9, square root of 9, minus the square root of 4, which is 3 minus 2, which equals 1. So we get two solutions for this problem, 0 and 4. Awesome. Let's do one real-world application, and then we will be done with this video. Okay, using a radical equation. For Meteor crater in Arizona, the formula D equals 2 times the cube root of V over 0.3 relates the diameter D of the rim of the crater in meters to the volume V in cubic meters. What is the volume of Meteor crater? All values are approximate. Alrighty, so we're going to start with this issue of what it says here, which is the diameter D of the rim in meters. Well, they didn't give it to us in meters, they gave it to us in kilometers. So first thing I have to do is recognize, well, what is that in meters? And I know my students know this quite well. That's your good old metric line. Take and move it 1, 2, 3 places to the right. Put in your zeros, 1,200 meters. So we'll be using that on the next slide. Okay, so we're plugging in the 1,200 meters for the distance equals 2 times the cube root of V over 3/10. So we're going to get rid of the 2 by dividing. 600 equals the cube root of V over 3/10. We're going to cube both sides, which is going to relieve us of the cube root there. 600 cubed is 216 million. Is that right? Hold on, let me double check that. Yep, that's right, is equal to V over 3/10. And finally, we're going to multiply both sides by, whoop, I'm out of space here, 3/10. Wait a minute. Okay, so I can kind of fit it in there. 0.3. Just recognized a new feature of the video making app. All right, and when we multiply that, we end up with an answer of 64,800,000 for the volume. So that's 64,800,000 cubic meters. That is a very big crater. All right, guys, hope you enjoy this slightly shorter than usual video. See you in class.